for joining us. This is Paul Wilson.
Chris Emke.
And you're listening to Diesel Performance Podcast. Chris, huge sale coming up at Duramax Tuner.
It's been a wild ride to get to this point. Just everything you have going on in marketing, and then we work together on the backside a lot with, sales, promos, stuff like that. So we got really creative this month.
That's right.
We want to do something different, something a little unorthodox for what we usually do. We have a huge couple weeks coming up.
So everybody who buys an upgraded turbo should also buy a boost test kit. Now,
Why, Paul?
Well, okay, great question, Chris. You probably have a boost leak and you don't know about it. And that just goes for everybody.
That's a loaded statement.
Everybody listening to the show, regardless of what your truck is, you probably have a boost leak and you don't know about it. So a boost tester will help you find that.
Think about this, Paul, right? Every truck that's out there, the guys that are listening to this have spent money on their truck in one way, shape, or form for an upgrade.
Yep.
Whether it's a 12 valve and you buy a fuel plate and an injector, or a J-hook for the turbo wastegate, or a turbo whatever. You get into the newer stuff that's tunable, you're going to spend money on tuning, right, on these trucks. We're spending money on our vehicles because we want to see a performance gain and an efficiency improvement. Well, a boost leak could potentially ruin all of that, and you might not even know that, right? So it's more of like an awareness and an insurance policy that the truck is operating correctly. And these things have been flying off the shelves, like very, very popular product for us. We offer a wide range of products,
sure, and
support.
That's what I was going to say there is I think you should buy a Stealth Turbo, and I think if you're going to buy a Stealth Turbo, you definitely should buy a Stealth Boost Tester kit. Mm-hmm. Now, boost testing, just in general, is something everybody should go do.
Every other oil change or every oil change. It should be a staple in my opinion, any turbo application.
Absolutely.
Yep.
But one thing we've learned over the years is most of the boost test kits out there suck. The regulators are crap if they have one at all.
Had a couple guys this week. They bought faceplates from us, but not the regulator because they had one. They're like, yeah, our regulators were junk. We need something a little more durable. So
boom,
those things happen. So we offer a package, right? A package for everything, and pretty much any Duramax got you covered. Cummins from 94 all the way to 2021 got you covered. Power Stroke guys, if it's an 03 to 07 6-liter, we got you covered. We are working on some of the newer truck stuff as well. But for the mass majority, like we have something that is available.
That's right. And the unique spot about it, like you had mentioned, the faceplate, is that the Stealth Boost Tester actually connects to the front of your turbocharger, whether that's the inlet adapter or directly onto the faceplate of the turbo. We have some different options available for some of the trucks. What it essentially is doing, though, is it's testing, can the compressor actually hold air? That's crucial. We find a ton of factory trucks cannot.
Boost leaks, yeah.
And then number two, it's also testing the connection from your turbo to your hot side intercooler pipe, which is usually where like the traditional old school kind of cheaper boost testers fit in. If you're testing there, that means you're not testing that connection, which I don't know how many guys have had to go through chasing down a boost leak they can't find, only to find out it was right there on from the turbo to the hot side intercooler pipe. So the sale running from June 21st to July 9th is going to be, you can buy a Stealth Turbo and you're going to get a free Stealth Boost Tester. Now, the regulator and a faceplate and an inlet adapter would run you $235 to $255. You're getting the whole boost test kit for free. So you get a high quality, super durable, liquid filled gauge HD regulator along with the corresponding faceplate or adapter that's going to fit your turbocharger. So it's a killer sale, and it is available for those that's like about a 3-week range. Now, hey, a lot of you guys out there are tuning customers, tuning fans. You need tuning for your truck. Guys, I don't have necessarily a discount, but we do have some special edition, limited time offered only hats that say Tuned It. That's our new hashtag, Tuned It and Duramax Tuner. We got a rack of those. Once that box is gone, they're gone. We're going to give them away free with all of the tuning orders that have some sort of shipping included. So if we're going to ship you out a switch or hardware or something like that, and you've ordered tuning, we're going to get you a free Tuned It hat to go right along with those.
Then we have some product releases. So we talked about it in last week's episode. I just kind of want to go through everything. It's important. I'm really excited about these things. First and foremost, we have our L5P 67 G2 Turbo. These have already been circulating in the market. We've been selling them, but we haven't done our hard launch where we have them on the website and we market that.
That's right.
So that's number one. Number two, the long-awaited HE351VE and the HE what's the other
HE
verbiage?
300 VG.
VG, man,
Yeah.
I'm done. It's a 351 VE in my book. Basically, it's a 6.7 Cummins turbo. It's a 64 millimeter drop-in. It ranges from 2007.5 all the way through 2018. We've done a lot of extensive workings on the exhaust side of things. There's some really cool technology around that turbocharger that's going to set that turbo away from some of the competitors in this space.
Yeah.
We're really, really excited to get that to market. It's been a long time coming. And then we have 2020 switch on the fly power stroke support.
That is another really cool product where the 15 to 19 power stroke stuff we have is very popular right now over at Calibrated Power or DuramaxTuner.com. But getting into the 2020s was a little bit more involved. Turns out we couldn't do a remote flashing device for the ECM. So instead, we're actually going to launch a bench flash service where we'll you ship your ECM into us. We put the tune on it. We ship it back with a switch and all of the hardware, which would be like EZ-Link that you need for your transmission tuning. So you get it, you install it in the truck, you flash your TCM tune, you install your switch, boom, you're down the road, and we're good to go. So that's going to be a really, really fun product for customers.
Definitely a cool product. The gains are ridiculous. They're very impressive, but it's just one of those things, man. The newer trucks are just getting complex.
They really are.
They really are.
Speaking of power gains, we have to go through a lot of certain verification procedures to be able to publish power numbers. One of the things we've done is we've completed all of our verification. We know how much power the trucks make. Now we just need to kind of put all of that into a context that's going to be included with the product launch. So if you're looking for like really specific details, I know a few of you have already messaged the Duramax Tuner Facebook page or the podcast Facebook page. Please continue to do so. We'll be releasing details all at one time. So come next Monday, June 21st, we're going to be able to tell you and answer all of those really detailed orientated questions that I've kind of already been getting from the guys who are excited about it. Chris, speaking of excited about it, I am really excited for today's episode. You and I are not going to be a part of it.
No, but I think it's one of those things where it's a real hot topic. And this hot topic comes in when guys start talking about turbocharger upgrades and the overall operation of how the engine functions around turbochargers. And what that is drive to boost pressure ratio. So boost pressure is the pressure that the compressor wheel pushes through the intercooler pipe, the intercooler itself, and makes its way into the intake of the motor. Drive pressure is the exhaust pressure. Okay,
Sure.
So that's the pressure leaving the turbine, having to go through the exhaust itself. And
I kind of think of it like this. Boost pressure is what's going into the engine,
Yep.
and drive pressure is what's coming out.
So what's going into the head, boost, what's coming out of the head, drive.
Yep.
And when you have a very efficient setup, that boost to drive should be like 1-to-1. Okay, that's ideal, right? That's perfect
what
world.
people talk about. Yeah.
But in reality, in a turbo application, things like that, you're going to see, 1 to 1.2, 1 to 1.3, and we've seen boost to drive pressures, guys talking online, 1 to 1.5, 1 to 1.6, like some crazy numbers. And that has an impact. That has an impact on EGTs. That has an impact in just the overall engine temperature and engine operation. It really has an effect of how the engine functions as a whole unit.
Yeah, and actually, what's interesting? So we'll jump to the point here. So Nick Pregnant's over at Duramax Tuner. Duramax Tuner, of course, one of our sponsors and where Chris and I work. Nick we just wrapped and published a video on drive to boost pressure ratios. And what's funny, Chris, is when we were working on that video, we had heard a lot of guys talking about 1-to-1 and wanting a turbo that was going to be 1-to-1. And then we started like really digging deep into some data logs and some turbo R&D and stuff like that, and found out like that idea of 1-to-1, it's not just can it be done, it's when can it be done, and in what tiny little window of perfect operation are you going to see it, and then what do you see the rest of the time? Like, did you know that it's actually really common on a VVT to see 2 or 2.5 to 1 just driving?
Wow.
So there's things that, like, when we talk about this concept, I think even guys who are hardcore enthusiasts and been around the game a long time, a lot of this drive to boost pressure ratio talk stemmed from running S400s back in the day compared to an S300. So a fixed vane in a competition application.
I think what you have, Paul, though, just to kind of clear that up, is when you're talking about boost to drive pressure, there are differences. Just like when guys call in about fuel pressure, right? What should my fuel pressure be? There's going to be a variance to all of that. So when you're talking about, well, boost pressure to drive pressure is 1 to 2.5, that tells me that that's the early stages of getting that turbo in motion. That's the vanes clocked a certain way. That drive pressure is not bad drive pressure.
There you go.
The bad drive pressure is a wide open throttle run, running through a wide RPM window, peak power. So there is give and take with that.
There is, and that's where I think a lot of guys get lost in this conversation.
Yep.
And that's one thing. That's one of the reasons that I thought pulling the audio from this video, which this is available as a video, guys. You could jump over to the Duramax Tuner YouTube channel. You can actually watch Nick and have some of the visual references throughout it of actually seeing like when, how, and why does drive to boost pressure ratio matter. And I think that's a lot of things that guys who especially are going to be maybe have been around diesel performance but haven't done a ton with this lately. This is a really, really cool video where you can see some real hands-on examples and actually get a lot more in-depth with what goes into measuring that and why should you give a shit about it. So let's kick it over to Nick, and we'll talk to you guys in just a minute.
Hi, I'm Nick with DuramaxTuner.com. Today on Diesel Insights, we're going to tackle drive pressure ratios. If you're on the forums and you're looking at drive pressure ratios, you're reading 1-to-1, right? That's where you want to be. If you're buying a turbocharger, you want to find the turbocharger that works perfectly to get you that 1-to-1 drive pressure ratio. It doesn't exist. But you can get close at certain parts of the operating cycle of the engine. Drive pressure ratios matter because they're a great indicator of reliability, power potential, and how efficiently the engine's operating. First, let's get down to basics. What is a drive pressure ratio? Well, if you're an enthusiast in this market, you know what boost is. Pressure in the manifold, right? So on the compressor side of the turbocharger, you're used to measuring how much pressure is that turbocharger making, and you're relating it to how much power output the truck's making. Okay, now on the other side of that compressor wheel is the turbine shaft. And that turbine is using exhaust energy to drive the compressor. That energy isn't free. It's in the form of heat and pressure. That pressure is called drive pressure. So pressure in the exhaust manifold driving the exhaust turbine. So your manifold pressure is drive pressure. The ratio of that drive pressure to the boost pressure is what we're going to talk about. So in order to make this whole thing relative, we're going to call it a ratio. So if there's 15 psi of pressure in the exhaust manifold and 15 psi in the intake manifold, that's a 1-to-1 pressure ratio. If there's 30 psi in the exhaust manifold and 15 psi in the intake manifold, that's 2-to-1. That's not as favorable. The higher the drive pressure ratio, the more the turbine is working for it relative to the compressor wheel. We want to avoid high drive pressure ratios whenever we can. All right, so I just said 2-to-1 drive pressure ratio, not so great. Well, the reality is sometimes that can be useful. Pre-variable geometry turbochargers, it was normal to have drive pressure ratios fairly close to 1-to-1. And that's because you didn't have the ability to dynamically change the shape of the exhaust housing. With the advent of variable geometry turbocharging, we can really clamp down the vanes and change the geometry in the exhaust housing. And what that allows us to do is rapidly accelerate exhaust gas and get great spool up. The cost here is pressure in the exhaust manifold. So on a variable geometry turbocharger, when you're taking off from the line, you may have the vanes closed. As those vanes are closed and they're really, clenched down, your pressure in the exhaust manifold is going to go up considerably. So as you take off from a light, you may have 10 or 15 pounds of pressure in the exhaust and only 1 or 2 pounds of boost. As that truck gets moving, the vanes are going to open up a little bit, your boost is going to come up, and then you're going to have probably a 2.5 or a 3-to-1 drive pressure ratio. So you might have 15 pounds of drive pressure and 5 pounds of boost. As that variable geometry turbocharger transitions into the mid-range, that's when you start to see the turbocharger operating more efficiently, and that's indicated by a drive pressure ratio closer to 1-to-1. Are you going to see 1-to-1 in a VGT? Not likely. You'll probably see 1.5-to-1 or closer to 2-to-1 when the turbocharger is operating at its peak. Why do we look at drive pressure ratio? It's a good sign of durability. It's a good sign of, is the truck happy where it's making power? Is it able to make more power? And is it making power efficiently? So the closer we get to 1-to-1, the more efficient that power production is. You're going to see the truck off idle, not even close to 1-to-1, right? You might have 3 or even 4-to-1. As you get into the mid-range where the truck is at that 2300 RPM, where it's really happy pulling, maybe 23 pounds of boost, 24 pounds of boost, you're going to see it very happy. So that's going to be the closest that you're going to see to 1-to-1. As that truck transitions over into that 3100 RPM or closer to the shift point under full load, you're going to see it again go away from 1.5 to 1 or 2 to 1. You're going to see it probably go higher, maybe 2.2, 2.5 to 1. Depends on what kind of turbocharger, vane setup, fueling, all that stuff, right? But you're going to see it go further away from 1 to 1 again, indicating that the truck's not operating as efficiently as it was at 22 or 2300 RPM. When I'm tuning a truck or a new turbocharger and I'm looking at drive pressure ratios, I look at these things relatively. Okay, there's no magic number that I'm targeting. I mean, sure, I want the lowest I can get, but if I looked at a turbocharger previously and we were running 2 to 1, and now I put a new turbocharger on and we're running 1.8 or 1.9 to 1 at peak, that's comparable loads, that's an indication to me that the truck is more happy, that our turbo design, our turbine design, is been more efficient, and we're going to get more out of the truck at that area. So basically the truck is happier there. What do I mean by happier? Well, probably the EGTs are down, probably the boost is up slightly. Anytime you have that situation, you have more durability out of the truck and less fuel consumption. Durability is great, right? We don't want to fail exhaust gaskets. We don't want to superheat our bellows. We don't want the truck operating hotter than it needs to because, of course, it's consuming fuel when it does that. Inefficiency can be seen in high EGTs, and it can be seen in excessive fuel consumption. So as your drive pressure goes higher than whatever the relative previous was, so let's say you start at 2 to 1 and now you change turbochargers and you're at 2.5 to 1, the truck's going to consume more fuel. Why is that? You're costing more turbine energy. Anytime you're costing turbine energy, that comes in the shape of fuel. Okay, so we want to avoid that. All right, so you've heard why I think drive pressure ratios are important. You've heard kind of what you can tell by looking at them in a relative sense. So how do I measure it? Well, let me tell you. I have this turbocharger in front of me. This is an HE351VE. This is a variable geometry turbocharger, bolts to the manifold on a Cummins. If I were measuring drive pressure on this turbocharger, which is necessary if I'm going to get a drive pressure ratio, I would measure as close to the entry to the turbocharger as possible. So if I could get a port either on this side of the turbocharger or on this side on the manifold, that'd be great. What we don't want to do when we're measuring drive pressure is bias towards one cylinder. So the closest you can get to the convergence of all the cylinders and the further away you can get to the cylinders before you get to the turbine, the better. The reason I say that is the closer you are to a cylinder, the more pulsation you're going to see in your drive pressure number, and that pulsation needs to be averaged in order to get a useful drive pressure number. So if you're seeing the drive pressure gauge go like this, that's not a useful thing, and that's what you'll see if you put it close to one cylinder. Also, when I'm making a drive pressure setup, I like to use a piece of 1/4-inch copper coil. Run the coil up, and what that's going to do is allow the exhaust gas to cool before it gets to the pressure transducer. Now keep in mind, you're going to see pressures of probably close to 100 psi if you're in a performance application. You may see more if you're in a compound turbocharging application. So you want to use probably an electronic pressure transducer that goes 0 to 100 or 0 to 200 or 250. You want to take care of that pressure transducer, and you do that by using a 1/4-inch copper coil, coiling it, letting the exhaust gas dissipate its heat before it gets to the transducer so it doesn't damage the transducer. What that'll also do is keep the soot out of the transducer for as long as possible. Now the Ford and the Dodge use a factory drive pressure setup, and that has a nice buffered metal filter in that, and what that does is catch the soot. So just keep in mind that your copper coil is probably going to get soot in it after a while, and it's important to clean that out once in a while if you want accurate readings. Of course, drive pressure is only half the game. You have to have an accurate boost reading as well. Your factory map sensor may not go as high as you need. Make sure you have a gauge that goes as high as the turbocharger is making. So most factory map sensors max out somewhere around that 37 psi number. If you're in a performance application, just make sure you have a map sensor that goes as high as you need to measure the boost. Ideally, they're electronic, so you can see them on a data log, and that way you can really see load. You can see MM3, so total fuel used. You can see RPM, and you can get a constant point at which you're measuring drive and boost. Do that division for drive pressure ratio. That way you can compare if you change something in the turbocharging setup. You've got the drive pressure setup wired, you've got a good boost reading, you're out on the street, what are you looking for? Well, it's nice to be able to compare before and after on turbocharging setups. So certainly if you're in the market for a turbocharger, this is something I'd love you to do before you put the new turbocharger on. It's going to give you an idea of the operating range of your engine. You're going to get to kind of memorize where your drive pressure ratios are at different points in the load and RPM range, and you'll know when you put that new turbocharger on, where did things shift? Okay, so what I look for when setting shift points is when does my drive pressure ratio get crazy? Right, so as I get towards the end of the rev limit of the engine, you're going to see drive pressure ratios go exponentially higher. Okay, you're going to really get a picture of where the truck is unhappy. So you'll know, do I want to run this truck up to 3,500 RPM, or do I want to put a rev limiter in it because drive pressure is simply astronomical and it's going to cost me exhaust gaskets and up pipes and whatever else, right? So it's a good safety indicator. Another reason I love the drive pressure ratio is it's a good indicator of when things are changing in the truck. So let's say the truck develops a boost leak. You're going to see drive pressure stay high and boost pressure drop. So you have notes on how the truck was performing at one point, maybe 2 months ago, and now you go to a sled pull and your drive pressure is high and your boost pressure is lower. Well, something's different there, right? So it's another piece of data that points to my boost is costing me more power than it should. When you're getting taxed on boost, that's not a good thing. So you may have a boost leak. You may have something going on with the turbine. You may have something stuck in the intake. It may just be weather, right? But it's another piece of data that helps you make decisions as you go through the competitive sphere. I hope this was a good primer for you on drive pressure ratios. Now you know where to get the data, where to install on your manifold, how to do the math, and why it might be useful in a competitive situation. Of course, there's more considerations to this, specifically what happens downstream of the turbocharger. Because that pressure that you're measuring in the manifold, that doesn't just come from the turbine. Especially on emissions-equipped trucks, there's a lot happening after the turbocharger, and those elements can greatly contribute to your drive pressure ratio. We're going to hit on those on the follow-up video here, so stay tuned for part 2.
Chris, I know I learned a lot of stuff while watching that video. What'd you think?
Nick never ceases to amaze, right? I mean, there's always some educational content that he's able to feed into my head from time to time. And this one was a really good one. There's a lot of components on a truck where, guys, like I'd mentioned with the fuel pressure earlier, or talking about exhaust gas temperatures, that you have this idea of what's okay and what isn't okay, but there's also needs to be an understanding of the operation and when those temperatures matter.
Context.
Right?
You need context
correct.
around these data points to have them make sense.
This, I think, outlines, right, as a better way to put it, is it outlines what you need to know and what needs to be understood before talking about drive pressure or talking about boost pressure. And I think it kind of builds that understanding of, what you need to do for upgrades in the future as well.
There you go. So. Absolutely. Guys, speaking of upgrades in the future, one of the things you're going to run into is troubleshooting problems and either hiring somebody to be your mechanic or having to be your own mechanic. Right. And we have had these two segments going on here for a while now this year, Chris, with Sean Lynn from our customer service staff and Jeremy Garnett, our super tech out of the shop. Well, for today's episode, I kind of brought these two guys together, and we really just hashed out some fun stuff that we've been dealing with, things we've seen at the shop, and getting some advice from these two at the same time. I think is a really, really cool part of the show, and we're going to try this from time to time, guys. Also, a quick heads up, I know Jeremy wanted me to share, Hummer project is underway. If you're not following Duramax Tuner's Instagram channel, you really, really should be, because Jeremy's documenting a ton of it there, and also at his Instagram page as well. So make sure you jump on and follow Jeremy for some more content. But for now, let's kick it over to myself, Sean, and Jeremy, and talking about our customer service super tech smash up segment. All right, listeners, I'm back at you. I thought last time when we had our super tech Jeremy Garnett, how the hell are you?
I'm wonderful. How are you?
And our awesome customer service rep, Sean Lynn, how the hell are you?
Good, how are you?
I thought you guys being on the show together were great.
Yeah.
How'd you guys feel about it? Did you feel like, Sean, tell me, did you feel like Jeremy stole your thunder?
Maybe a little bit, but I like talking to him.
And Jeremy, I know how much you love everybody from the tuning team.
Oh, yeah. No, they're just wonderful people.
That's absolutely. This is a chance for us, if anybody's ever worked in a shop that has different departments before, there is always some certain understandings that you have of what that other department does and doesn't do. So, for example, when we have mechanics and somebody from our tuning and customer service team here, we run into questions about, like, switch installs and who should boost test it next and shit like that. And so I think we found a vehicle that the two of you kind of overlapped on working on. I thought it would be fun to talk about in this segment. We recently picked up a 2019 Roxor with the automatic transmission. So the Roxor is that little like Jeep look-alike thing from India, made by Mahindra. They're really, really cool. They come with a little 4-cylinder diesel, turbocharged, and no intercooler. Over here at Calibrated Power, we've developed an intercooler, a turbo, and a whole slew of other parts that go along with it, and of course our custom tuning. So, Jeremy, you and I got to work on a really cool part for this, and that was the HD grid heater hold down.
Right.
Can you talk a little bit about what we found? Can you talk a little bit about whether or not you think that part is needed on every single Roxor ever made?
100%. So, reason number one is that the factory uses they don't use a clamp on the bottom of it.
Yeah.
So, and it's just, there's one little tiny little bolt and a rubber boot. So the factory Roxor, I mean, will push up to what, 9 pounds?
Yeah, I think it's 9 PSI.
It's like 9 PSI. I mean, okay, we tested it and Boost tested it. It leaked at 3 PSI.
Yeah, like hard leaked.
Hard leak.
So the grid heater, right where the grid heater is on the top driver side of the engine, you can actually see the little square looking plate in the bellum there, and right at I think it's at the bottom of it, if I remember correctly.
Right.
It just pisses air. I mean, just the minute you hooked up the stealth boost tester to it, it just I don't
barely
know.
in there.
I don't know that you even got up to 3 PSI because it was just pouring out of there. And this is factory. This is a completely stock no mile unit. And it couldn't hold boost.
Yeah, and having no intercooler.
Right.
So
right. The loss is just immense. So the HD grid heater hold down is a billet aluminum piece. So you know it's really strong. And it clamps in there in the right way, and it uses T-bolt clamps, so it doesn't use worm drive stuff. And it uses all really good hardware, and it has a special bolt that holds it all down.
Right. So it has a special bolt that holds it down, and it's also so it's machined.
That's
so
right.
it's done on a machine, and it's double O-ringed.
Yeah.
So where it actually goes over, it actually double O-ring. So it's actually just sealed with the double O-rings, and not just a boot going over a nipple. A nipple. It's
and it works. So we boost tested at 3 PSI. The stock unit couldn't hold any air. We put the HD grid heater hold on. I say we like I turned a wrench. I literally didn't even hold a camera for this. Jeremy did all of the work as the super tech. And Justin, our producer from the show, filmed all of it while I stood there and asked what's going on. And then we boost tested it again afterwards.
Right.
And what'd you take it up to?
we had it up to 12.
So up to 12, no problem. And we've tested them up to 20, 25.
Yeah, we went up to 20, 25 easy. This one we're actually doing documentation and video and stuff. And so we were showing it on camera and stuff, and we actually went up to 12 and
it holds perfect.
And it holds perfect. I mean, it just sat there and didn't even move.
Now, this exact same Roxor, then we get done with the video, so we got to show off like the stealth boost tester for the Roxors. We got to show off the HD grid heater hold down, which if you're a listener who has a Roxor, get a hold of us because you're going to want those two parts for sure. And then it went over, and Sean Lynn, superstar extraordinaire, got to come down, and you got to get your hands on the truck.
Yeah, earlier in the week I came down here and I installed our boost increase valve, which is pretty tight in there, but pretty straightforward regardless.
Real quick, give our new listeners a boost increase valve. I know them back from the LB7, but I think a lot of listeners probably haven't dealt with them.
Yeah, so it's basically for the older fixed vane turbos that have the external wastegate. It's a valve that goes in between the hose on the front of the turbo and the actual wastegate itself, and it just makes it so that it takes more pressure to go through there.
That's it. Yeah, it instead of it opening at whatever 5 psi or 10 psi, it'll add 5 to 10 psi on top of that. So really nice little piece, and they're cheap. They're easy to install. It's a set of side cutters and a flathead screwdriver. I think is legitimately all you need for that. Now, I have a running record here in the company. I don't know if you know about this, Sean Lynn, but I have taken up to 3 hours to do a switch install, and I have taken up to a full 45 minutes to get a boost increase valve installed properly. Turns out there's a little arrow on them, and if you don't read where the arrow goes, you can do them wrong. How long did it take you to put yours in?
It probably took about a half hour just because it was so tight in there.
Yeah, they are buried down in there, aren't they?
Oh, yeah, it's pretty tight. I had to put a light on and stuff and get some long nose pliers. it was pretty tight.
Man, so you're creeping right up on my record here. Okay. All right. I'm going to protect it. Don't worry. I'm going to go back and help one more customer. One more customer who's got a lot of time to waste get a hold of me. All right. So you did the boost increase valve, and then what else did you do to the truck? Or to the Roxor, I should say.
Yeah, I took the ECM out, and we flashed it here with our switchable tuning. So I reinstalled it. It's only 4 bolts, really easy. One electrical connector. Anybody can do that. And the switch itself, I ran the wires from behind the dash, and they just basically tie in with a T-harness under the hood. Really straightforward install.
That is one of the nicer switch install packages that we have. It's not quite as easy as like the calibrated power dial for like the 2.8 liter or the Cummins that just plugs into the OBD2 port, but it's damn close.
Yeah, it's basically like the 6.7 Power Stroke switch that we sell.
Yeah.
Because that one is a T-harness as well.
That's right. That's right, yeah. So they're really slick. And now that allows customers to switch on the fly. Now, when you got a stock Roxor, they're 50 horsepower to the rear wheels, I think is what we've measured them at. It's like 48 or something like that. It's about 50. With tune only, I think we can get them up into 75 or 80 horsepower.
So that's 75 and 120, Sean? Or 75, 105 or something?
Max effort tuning, I believe, is 117 horsepower.
Okay.
Oof. That is cooking in that little thing. I'll just tell you that from driving that thing through the fields when it was stock, and then I've gotten lucky. I've gotten to be able to drive it with the tuning, with the turbo, with the intercooler, yada yada. That is hot moving. But this one's an automatic, and I haven't got to mess with the automatic yet.
I've only driven the manual one before, so I don't know how the automatic drives, but the manual was a blast to drive, so I'm sure the automatic is just as good.
Yeah, it turns out we would be able to drive our automatic one, except Jeremy's been over there wrenching on it, monkeying around, breaking everything in the transmission, and now nobody can move it. What's going on, man?
Well, I got it fixed.
That's such a mechanic response. I fixed it, so what if it was down for 2 weeks? What do you want? What?
It was broken, but I got it fixed. But no, we're trying to figure out trans tuning.
Yeah.
So, it's R&D. It's what it is, what we do, what we love. We were just messing around with it with the valve body in it, since these don't have a standalone TCM. The valve body is basically how you tune these because everything's included.
Yeah.
We took it out, and it's actually basically the same valve body as a Chevy Colorado. So we took that out, and we were messing around with it. We had a spare one around, put that in thinking that we could maybe not ruin the original one.
Yeah.
And then it just it wasn't happy.
Yeah.
So we went ahead and we had to put the old one back in, and it just didn't like it. Didn't like going back, switching. Didn't like the valve body switching. So
yeah.
After just messing around with it, monkeying around with it, we got it to go through all the gears and not throw any codes anymore.
I will say I have been around diesels for longer than I care to admit, and vehicles my whole life. And valve bodies and fluid passage and the hydraulics of a transmission still feel like a total mystery to me. I know that fluid goes in and pressure gets applied and gears get made-ish, but not like gears like you think.
Right.
That's about as much as I know about automatic transmissions. So, yeah. Sean, what about you? Do you mess with getting in there and because you build 6-speed conversion kits, so you have more experience with valve bodies than I do, that's for sure.
Yeah, it's a bit of a complicated process, but the end result is worth it because you got a 6th gear now and lockout 6th in tow haul mode.
Yeah.
I've built quite a few of them here, and usually the only time I ever have to deal with it on the phone is if a Cummins guy is losing line pressure in his trans. RevMax makes a valve body upgrade for the 68 RFE transmissions.
Sure. Yeah, that's a good call there. Awesome. Well, guys, I think this one's been really fun. Jeremy, that install on that HD grid heater, it went pretty smooth. And I know this because we videotaped you doing it. Mm-hmm. Do you have any pro tips for that install?
Take your time. Just because, when the pipe comes up and everything, it's like don't try to pry anything.
Yeah.
Just take your time, and then surfaces. Make sure the surfaces are clean because, when the grid heater goes back down, you have to. It comes with new gaskets.
Yep.
So just make sure that the surfaces are clean, or else you will have boost leaks. So
that's such one of the ones that you catch the guys who make it fight you the most on the phone, right, Sean? Like the guys who didn't clean the gasket clearly and like has a boost leak for the thing they just fixed. And then when they find it, you will never hear about it.
Yeah.
Like all of a sudden it will be total silence in an email thread or like the phone call just never gets returned and you're like, I think I know what the problem was.
Yeah, sometimes taking that extra 5 minutes to take something off instead of fighting an hour around it.
Yeah.
So sometimes it's just easier to take more things off and work and get a better visual of what you're working with.
I love that. That's good advice, man.
So.
Sean Lynn, you did the install on the boost increase valve and the tuning for the Roxor. Do you have any tips around that?
Like you mentioned earlier, the arrow on the boost increase valve needs to point towards the wastegate, and if it's pointing the other direction, that is not going to work.
I feel like you're just rubbing salt on the wound. I said I got it wrong. I said I'm sorry. I made it work. I fixed it. No, I'm just.
And for the switch itself, I just recommend that instead of just throwing the wires in there, use the wire loom that comes with it, zip tie it off so it's not flying around under your hood, you know.
Make it look clean, guys. Like take some pride in it. No, but for real, it does look so much cleaner when you do that, and you run into less potential issues down the road. I don't know how many times I've seen an LB7 or an LLY that's had a switch working for 5 years, all of a sudden show up at the shop for diagnostics, and you're like, hey, buddy, this broken wire might be the problem, and like they never ran it through the loom. It's just sitting next to the battery cables, and you're like, what are we doing? What are we doing? I get it. Awesome. Guys, thank you so much both for joining me. Jeremy, we definitely appreciate your pro tip.
Oh, no problem. Thanks for having me.
And Sean Lynn, we know that we love having you on the show, and I love the content that you're bringing to us. Thanks for joining us today.
Thanks for having me.
Listeners, stick around. Chris Emke is going to be right back on the show, and we'll wrap this thing up. Whew, Chris.
Dude, interesting to say the least. I really appreciate that them, taking the time to come down here and do that with you. Wealth of knowledge, that's everything.
You know, Jeremy, we've known Jeremy for a couple of years now.
Yeah.
So we've been working with Jeremy, and like when you go up, I just walked up today to Jeremy and was like, hey, how's this Hummer project going? And he's like, and then 2 minutes later, we probably got into the conversation for real, and then like all of a sudden I look down, it's 20 minutes later, and I'm like, okay, for real, I gotta go, but I will be back to talk more about this. And that's the way I feel like talking to him about working on a truck goes, where he'll play it shy up front, and then as you start to dig further and further into it, you get more and more detailed about how much fun it really is.
Yeah, no, definitely.
And
definitely
Sean Lynn taking out his time to come down and talk to our listeners, we really do appreciate that. So big shout out to Sean Lynn. We're going to make sure we include his social media tags in the show notes. So guys, go check that out. The other thing we really need all of our listeners to do,
I think it's time, subscribe, rate, share. We have these segments and we have these episodes going every week. So, we would appreciate it if you did subscribe to our channel, right? Our channel there. Rate it, right? 5 stars, nothing less. I wouldn't expect anything less. I take the time to do this, so rate it well. And share, because there's probably other diesel enthusiasts that would really, really appreciate to listen to Paul and I ramble.
That's it. Hey, if you think about how you found the show, let's try to help somebody else find the show that same way. For today, this has been Paul Wilson.
And Chris Emke.
Thanks for listening. Guys, I loved doing a joint